Hello, everyone. My name is Giselle Howe, and I'm here today to go over a webinar called How to Ditch the Defaults and Elevate Your Dashboards in Power BI. So a little bit of background on me before we get started. As I mentioned, my name is Giselle Howe, and I am the Senior BPM Platform Integration Manager at E&G Works Global. My background is focused heavily in manufacturing, more specifically, the intersection of manufacturing operations and design when it comes to BIM. I used to work for a manufacturer for nearly a decade, and now I work for a technology solutions provider, E&G Works Global, where we provide various services with BIM, BIM content creation, maintenance, all sorts of things. I work specifically with a lot of different manufacturer and non-manufacturer clients. So what you're seeing on the screen today is actually something that is quite a passion of mine, and that is data visualization. There are so many aspects to high quality BIM content, and one of which is data, which I'm sure all of you would be familiar with. What you're seeing on the screen is just a couple different visuals that were put together to show likelihood of utilization, meaning that if there was, if there was a lot of data that was missing, or if there was incorrect data, or if there is functionality issues or something like that, we evaluate BIM content to see how well that might be used or not used in someone's workflow. But what I want to show you today is how you can do things like this with your own BIM content libraries, because here's where that impacts your own teams. This impacts your own teams when it comes to productivity, or if there are training that you want to implement and other things like that. You want to have a consistent experience across your entire BIM content library, especially when it comes to Revit or even fabrication CAD map or other aspects like that. So what I want to show you today is how you can look at this with your own BIM content libraries as well. So let me go back to what I want to show you within Power BI. So before I get into the actual visuals here themselves, I want to get into what I want to show you today. What I want to show you here is obviously within Microsoft Power BI itself, and this is interacting with Python visuals. So those of you who might not be familiar with Python, it's a programming language that can be utilized in so many different ways. And what I'm showing you on the screen here, and will show you throughout this webinar, is it's just scratching the surface. So what I want you to remember throughout this whole thing is that I want you to think of it as not all these tools that you have to remember or have to track along with or something like that. I want you to think of it in such a way where you are inspired to come up with a vision and how you want to implement it, then you build the tools around that, okay? So that's what I want to address with this whole thing here. So to be able to do this, how to integrate Python and Power BI, there are three aspects that you need, three key components. So the first component is that you need Microsoft Power BI, obviously, it is kind of a given. The second thing that you need is Python, which you can go to, I believe it's python.org. I forget, you can Google it, but there's a Python website where you can download the exact version that you need, the latest version. So you would need Python, and you would need to incorporate it within your options right over here. Okay, there is a Python scripting option. You need to connect it in here. So once you have it installed, you need to connect it within the Python scripting, and it needs to detect that these things are talking to each other. So that is number two that you need. Number three you need is a smile. No, I'm just kidding. You don't need a smile. It helps. But the thing that you actually need for number three is called a Jupyter notebook. So those of you who are not familiar with the Jupyter notebook, what that is like this web-based program tool that you can put in notes, you can put in code, you can put in visualizations, and you can share those notebooks. Well, it depends on what you're trying to do, but you can show people what you're trying to do with that. So Jupyter notebook, if I go to the page for Jupyter notebook, I can show you what that looks like. you go to Jupyter.org, Jupyter spelled like this, by the way. Yeah, so this is a whole different thing here where you can put in your visualizations, your code, and yeah, you can share it here. I have not personally shared it, so that's why I was careful about what I was saying here. But yeah, apparently you can share Jupyter notebooks and collaborate on them. A similar one might be, I believe it's called Google Colab, where it's a very similar thing. So you'll want to install this here, and I'll be able to show you throughout this webinar why you want to use this in conjunction with the Python visuals. So yeah, without further ado, let's get going. So here, now that we've connected Python, the installation of Python to Power BI via the options here, what you'll want to do is, along the side here with these visualizations, you will want to select a Python visual to place on here. So this is a Python visual right now. It's just stretched across the whole thing here. And what you'll start to see along the bottom here, once you add a value, of course, from your data set, you'll see this bar along the bottom, and you just pop that up and a whole secret new world comes into play here. So there's quite a bit going on here. So what I want to do here is go through this a little bit step by step, because it's going to look a little crazy. So within Python, there are a lot of things you can do, and then there are libraries that you'll want to import as well. So there's a little bit more to it than just simply installing Python. You'll want to install certain libraries that you'll want to use. In this specific case, you'll want to install pandas, you want to install NumPy, Seaborn, and Matplotlib. There might be a couple others as we go, but those are some very specific ones. There are documentation articles for every single one of these I mentioned. And by the way, even though I'm going through this right now in this webinar, I can provide all this after the webinar too. So it's no big deal there. So don't worry about that. So the first step in incorporating all of this stuff, even if you don't know any Python at all, you'll want to import these libraries. So that's literally these first few lines. So it's saying that you're importing pandas and you're importing NumPy, Seaborn, Matplotlib. So that's the first part. It needs to know what packages you're installing. The second part, in the second part here, you'll want to read a data set. So I noticed there's a couple different ways to integrate Python visuals with Power BI, and some of it had to do with what values you were dragging into here. So I'll say that I haven't tested out specifically what you would do here if you wanted to do it that way. In my case, I'm used to just straight up just using the data set, just importing the whole thing and just hard coding it. So that's the method I'm showing here today. So we are saying for pandas to read a CSV file in a specific location, and that's what I have read here. So it's reading a certain path. It's going down further where it wants to drop any duplicate entries if there were for some reason. I don't believe there were in my data set, but there was. And in this case, we are sorting these values. So by the way, anything I'm mentioning, usually on like, let's say Overstock, I believe it's called, or I forget what there's lots of code online that you can look up snippets of what to do, where you can look up like what snippets to use. But this is saying that you're sorting it, and you're sorting it by file size. The reason why I'm doing this is because I want to show a visual that is showing in, it's going from the largest to the smallest in the file size. So this data set here happens to have tons and tons of Revit families. It has all the file sizes of those Revit families, and it has their Revit categories as well. So it is sorting them. So if I go back out here, it is showing the largest file sizes down to the smallest file sizes. And it's categorizing them based on the Revit categories, just to split it up a little bit. So that is the whole first part here. And let me scroll down a little bit further because I did some crazy stuff with this that I don't want to get into yet. But the main part that I want to get at is the essence of how you make this. The next part here is that you'd actually create the plot. So that is really, it's specifically exactly this highlighted part. All the other stuff is like some crazy stuff that I'll explain in a minute. But what this is called is a swarm plot. So what this does is it's creating a bunch of dots here, and it's putting them in the various categories. It's organizing them by the file size all along the line here. It is saying along the x-axis, you have the Revit category. Along the y-axis, you have the file size. You're using this data, which is the sorted data set. It's saying the size of the dots, and it's saying to use a certain color palette. That's really the essence of what is going on here, like without any crazy stuff going on. That's really the essence of how you create any of this. Lastly, to actually plot that, you need to have something called plt.show, because without that, you get errors. I mean, basically, I may as well show you. I've seen this like a bazillion times. So this should make it have an error. If I play this, this is how you make it run, by the way. So it is thinking about it for a second here, but it tends to have an issue. Yeah, so this, I've seen this about a bazillion times, and you will too. You get to join in on the fun if you want this. So basically it doesn't, it's not very clear in why it says that that's a problem. So it's not like it said you were missing plt.show. It's not. So that's why I recommend the use of a Jupyter notebook, because the Jupyter notebook is a little more, I think it's a little more user friendly. It tells you a little bit more if there are problems or something like that. So, but yeah, in order to actually have this show, you need to have the actual plt.show. So now for one of the crazy things that I want to describe here as something I've used to customize this is I've actually customized user inputs. If you kind of noticed a little bit on my screen here, I was playing around with color palettes and different colors of how I wanted to do this. So I actually have like 3 different ways I could color this. I've got annotations built in here, and I made it all happen by simply putting in like different user inputs. So right now it's a user input of 1. If I did like a 2 or a 3 or a 4 or a 5, I would color things differently. There's one in particular I want to show you, which is option number 4. And the reason why I want to show you this one is because I've seen on Revit project health dashboards that there are sometimes visuals where you'll see like, oh, a certain percentage of Revit families are above a certain file size, but they don't provide context of like which families those are or which categories they fall into or anything. And so if you actually visualize it differently here, you can see that where that context would have helped. In this sense, if I was above a certain limit, you're seeing that in this sense, doors, the category, there were several that were over, lighting fixtures, there were a couple that were over, mechanical equipment, a few, but then look at furniture, pipe accessories, pipe fittings, electrical fixtures, communication devices, and some generic models were all well below a certain file size limit that was specified. So this provides more context of, well, which categories were those of families that were exceeding a file size and whatnot. I can further specify the limit that I want to do. Right now it's looking at 3,500 kilobytes. If I did specifically, I believe it's 2,000, and then if I did like option 5, what this will do is say that it wants to zero in on, well, is there something where I want to look at a specific category? Does that one exceed a certain file size that I want to have? And if I make this one go where I want it to go, it will then update again here in just a second. But the point that I want to drive home with this here is that it really zeroes in on a specific one. So in this case here, it is saying that literally one file out of all the pipe accessories exceeded 2 megabytes here. So this comes into play when you're thinking, well, you know, how many files are over a certain size? How many am I really using in a Revit project? So really, when it comes down to it, things like mechanical equipment, it's okay if they're larger file sizes because you're not using as many in your project. Whereas like pipe fittings and pipe accessories and stuff, you're using like a lot more. So you definitely want those lower in file sizes. So that's kind of why you'd care about something like this for your own Revit libraries. I can also show you in a separate example here, just to show my point with let's say a line chart here. This is actually a test we've done in a very similar way, where we've actually taken Revit families that were a certain file size. I believe these were a bunch of valves, and we placed them in a Revit project file, and we duplicated and saved it over and over and over again to see what was the effect of it on the overall project size. As you can see, it exponentially went up for the number of Revit files that we had, or Revit families we placed, but the actual Revit file size really, it did not go crazy. It had that initial hit, but then it did not go up at the same rate. So this is the kind of stuff you can try out with your own libraries too, where you could see how big of a file size is really a big deal per Revit category, and where you place it in a Revit project and you save it and duplicate it over and over to see what it does for your own Revit projects. So something kind of fun. I could get into so much other stuff with this too, but I wanted to show you just the basis of this. Really, the main takeaway with this is that there are so many things you can customize with these charts when it comes to what the Y labels look like, the X labels look like, the colors, the grids, the overall look of the background of the grids, the titles. There are so many things you can customize, and I think probably I realized that this could have been an hour by itself on just this. So I'm going to move on. So boxing is very similar. This is very much like a box plot, except it shows more segments if you have a lot of data. So this is a very similar thing to the last one. It's just represented with boxes instead. And if I had a little bit more time, I know what I could do is I could actually annotate the outliers in this case. So they are represented by diamonds. So you could code it in here to actually do annotations for outliers. So a very similar thing. You've got the libraries you need, the data you're importing, you're sorting some things, you are setting up colors. In this case, I did a palette that I set, or like a list of them that I set myself. And the actual box, or box and plot, this is literally the code you would need to do it. That's literally it. And then of course the plt.show, and all the rest of this is all customizing things with the X labels, the Y labels and stuff. Because as you'll see, in this case, it was overlapping. So I made things, not overlap and stuff like that. So there are so many rabbit holes you can go down to format this stuff to look right. So that's the essence of that. There's a little bit limitation when it comes to like the swarm plots and stuff. It sometimes doesn't show all of the dots in the data set. So what I want to show you actually within Jupyter Notebook instead is what that's all about. So notice that Power BI did not have an issue plotting the swarm plot. It just did it. So within Jupyter Notebook, though, it actually is a little more sensitive, which is why I like to use it. So I put in all the same code in here, and it actually gave this warning down here saying, a certain percentage of the points were not placed and things like that. It gives this warning, even though Power BI was cool with it. So what I want to show you though is that even though it shows this, it's recommending that you could try another plot, which is the strip plot here. So what that is it just looks like this here. This one just happens to compare out of box content to the stuff that my team has built internally. So you can do that with data visualizations, and you can make them, this is called dodging, where you can make it, they just stick side by side. So that's literally just a little snippet you put in the code. But I want to bring this up because, well, in the world of data visualizations, there are sometimes unintentionally or intentionally misleading visualizations, and it's really important to know and to show your viewers what is accurate and what you're considering and things like that. There is actually a book that I'm reading right now that I really recommend. It's called How Charts Lie. And it really does get into, like, if there's a poor design, you're not going to display stuff properly. So back to our example here, when it comes to the swarm plot having a little bit of a problem here, I tried out the strip plot as an example here to see what that would do instead. And as you notice here, it's a little more clustered together, I noticed that my annotations were, they kind of, if I ran this exact same code again, the annotations don't exactly line up and things like that. So I might still use the swarm plot and I might add maybe a note or something, but the real takeaway here is that you want to make sure that everything is represented the way that you intend. And what you can do to confirm that is actually not do it visually as well. Let me show you where we can verify that. So this whole thing is how this large bit of code is actually how it came up with how to highlight exactly this. And if you ran exactly this code, it's saying that there is one item that is true out of that entire list, hence why one of them is colored. And if I made that one actually show up, like what is that exact file? It shows just one. It's not showing there's, you know, extra files or something like that. So in this sense, this is still accurate. I still would probably use it. I think it looks cleaner compared to the strip plot that kind of had stuff kind of everywhere, but you do you, all right? The important part is to know that this stuff can happen and you want to represent things properly because you don't want to mislead people, especially if it was unintentional and stuff like that. So yeah, very similar. This is a very similar thing where that is what you can do. Yeah, lots of different formatting has happened here. I'm not going to be able to fit all that in a webinar, but I can provide this after the fact for anyone who has questions. But yeah, a similar one that we could get into next, if we're looking into, let's say, benchmarking, you can do this as well if you wanted to compare, let's say, a couple different categories of things. So in this sense, this is called a rain cloud chart. I noticed that there are two different ways to create a rain cloud chart. One of them was kind of basically from scratch that I followed from a tutorial, and the other one was with a built-in or not built-in, but an actual Python package that you could install. I happen to like the second one, so let's just show this one. They're very similar. I just think the second one's a little bit easier to control because you can control the shape and the height of all this, of what this looks like. So let's go under the hood a little bit with this one. So this one's the same idea, okay? You are importing in the libraries. In this case, you need another one that was, I believe it's Petite Prince, I want to say it's pronounced, but this is the library. And you are reading a data set, of course. I have some other options built in here where I could do different categories here. This one is happening to compare pipe fittings. If I did, I should be able to, I'm going rogue right now. I'm going to see if I can type in pipe accessories instead and see what this does. But it should actually change to reflect pipe accessories instead as a category. Yes, it worked. But yeah, you can change this based on user input that I've specified and stuff in here. And the actual essence of building this chart is literally right here. You are saying that the figure is a certain size. You're telling it to do a rain cloud. You are saying the x-axis is the file size. The y-axis is the origin. I just have the y-axis labels hidden, which is another thing I'll get into in a second. And it's saying that it's using the data set that I have placed in here. This here kind of gets into the shape of what these look like. So that's kind of altering what those look like there. This is the color palette that I'm using. It's saying to go horizontally. And if you see anything in any code snippets that say alpha, it's kind of like, I kind of think of it as like transparency a little bit. So it just, I don't know, I just think it looks kind of nice, just a little transparent thing. But again, you do you. Yeah, so all the rest of this is customizing things here. And yeah, the other rain cloud is very similar in that sense here. You can specify the font size, you can specify if there are legends. This is if a legend is showing up, you can make a shadow show up behind the legend, you can have a frame around the legend, you can locate the legend. The possibilities are literally endless with Python, I think. So lots of things. Now notice I have the YTIC labels in this case, which would have been, I think in this case, it would have been just like literally 2, but I have them as just an empty list. God, I shouldn't have done that. I just ruined my code, but empty list. And the reason why I do that is because there's a lot of best practices when it comes to data visualizations. And one of the things is to really try to clean up everything to have non-essential items removed. A lot of times I see on dashboards and things like that, you'll just have so much data and so many things labeled and everything. And the thing is, a lot of it's redundant and you could actually remove a lot of it. So in this case here, I mean, we have the Y-tick labels as removed. I could have done other things here too, where maybe I changed the title to mention something about file sizes in kilobytes. And then I actually get rid of the X label in that case, because then it's like you're getting rid of some non-essential stuff here. And therefore that should update in just a second. So it's like it's getting rid of some of the text because you're using it already. You could probably do some other things where you could get rid of the legend and you could label, you could set an annotation to label specifically these two rain clouds, and then you get rid of the legend. Things like that you can do. I believe it's called the data inc ratio, where you can look at all the elements in your entire chart and you have it as a ratio of like what actually is the relevant parts, the actual data critical parts and things like that. So that was the data ratio. If you want to look into that further, I believe it was said by Edward Tufte, very well known in the data science community about best practices and data visualization. So fun stuff. Another one I want to show. Let's say you want to look at how old your files are. So this here happens to show a KDE plot, which is, I believe, a kernel density estimate plot. It's basically just saying like where do the majority of your files fall. So in this case, I had a lot of Revit family files that were created in Revit 2020, and they were approximately, well, they're less than a year old. And then there were others that were built in Revit 2019 and 2018, and they are around, it looks like anywhere from 1 to 2 years old. And the reason why we track things like this is because, well, software functionality changes over time. I've seen things happen where Revit content has worked in one version and then it experienced problems in a newer version. So when we work with our clients on this sort of thing and we build their content, we're very cognizant of what Revit version we're building in and that it works in multiple versions. So if you want to check this out with your own libraries, you could isolate things like, well, you know, there was a known issue in Revit 2018, and we have several files that are around this old. You know, maybe that's something we need to look into or something like that. So that's how you can do that with your own Revit libraries. If you wanted to look at actual quantities of files, we could do this with a hex bin, which is very much the same thing, except it's got a color bar on the side saying that it looks like I have quite a few files that are Revit 2020 builds. So I think, if I'm not mistaken, this data set that I put together is probably, I don't know, it's like 1,000 files. It was something else up there. So quite a big data set. So you can do it in a very similar way here. I forget to mention, yeah, if I actually went into here, again, you're doing the thing where you are importing the required libraries. You are reading a data set. In this case, I did some customizations with the colors here, but I want to get to the essence of what was built for sake of time here. But yeah, this here, it's saying you are doing a joint plot. You are using the data set that you have imported. You are specifying the X, or I'm sorry, the Y, which in this case is the Revit version, the X, which is the years since last modification. You're specifying a height of this entire thing. You can specify a space between the margins. The ratio of these charts here to this, you can specify so many different things here. And along the bottom here, I have things like I've relabeled some things and stuff like that. So that's really the essence of that chart. The hex bin is actually very similar. It's yeah, you're importing the libraries, you're reading the data set, you are specifying what the actual plot is, which is literally this right here. You're specifying the X, the Y, the colors, and the rest is all how you customize it. So lots of ways to customize this when it comes to the labels, the colors. In one case, I was doing like a custom color map. It was just crazy stuff. So along those same lines, we can do things called a lollipop chart. So this is a very similar thing where you could look across your entire library. In this case, I think it was looking at families that were older than a year and a half. And I set this up to actually highlight what is older than a year and a half. And this could move around as well. So very similar. We're importing the libraries that are needed. We have the data set. We are sorting some things. So in this case, it's sorting by the years since last modification. So it's basically, it's making it so it's not all jumbled all over the place. That's why we sort it. So that's what we're doing there. I've specified a color, like what to do if it is older than 1.5 years. So there's one, this is, I believe, a NumPy array here where it's saying if it's older than a year and a half, this is the color that you do. If not, you do the other color. It's very similar to, well, I think Revit's pretty similar. If you're building families, very similar what you can do there, if then statements. And same where you can also do the size. So it's showing the size of these little things as well as the lines. If this was much bigger, that's what Lollipop is. They literally make it look like a lollipop. So go figure. But yeah, in this case, I could actually change this if I wanted. Let's just say like, I don't know, we'll just do 2.5. Let's keep it a little simple, but this should actually change a little bit further and only like a couple of these. Yeah, so in this case, looks like one is older. Down here, I just, this is all Python code to make it annotate specifically this. So if I had older families than this, it would show those families. So this is exactly locating what is the oldest families in this entire data set, and it's just plotting them there. The reason why I show so many annotations is because if you haven't noticed by now, there are some limitations when it comes to Python integrated with Power BI. I know a lot of people like the interactive features, which I do too. And it's great for, you know, if you have those operational dashboards and stuff. But the thing is, a lot of what I'm showing here is more of like I believe it's more of like an analytical dashboard. It's you're analyzing a whole library. You're doing it maybe, I don't know, let's just say once a quarter. You're not doing daily interactive stuff like you would be on like your Revit project health stuff. So in this sense here, because there's no interactivity, I see it as like a creativity restraint here. Like, what can I do to get the essence out of a chart? So in this case, we wanted to know, well, what are the oldest families? So I made Python code actually print that here, and it will change if there are older families, but it'll print that there just because I can't hover over it. Now, to be clear, Python itself can do crazy things. It's just within Power BI, Power BI has the limits with what it can do with supported Power BI visuals. So really with any of these, you might see more annotations than what you would normally see just because there's no interactivity. So that's why I show that. Very similarly, we can get into, let's see, oh my goodness, I just went everywhere. Oh, there we go. So this here, if you were analyzing across your entire library again, you could get into something called it's a filled bar chart. So in this case, this took a Revit schedule. So a lot of the data that I've been gathering up to this point, it was something I've gathered with, like you can do it like Python scripts or you can do it from like the Revit API or something like that. This one specifically, you could do with just an exported Revit schedule of whatever you placed in your project. So it has to be set up a certain way for it to work. And if I click on this, what it's doing here, if I if I import the libraries, as we've said here, we do the data set. There's one little aspect here where I'm setting the index column, but there's this one part here called skip rows. So depending on how you do your Revit schedules, if you export that into TXT, which you then open up into Excel to then view that, you'll see that maybe like the titles or the headers or something like that might look a little bit differently. And if you notice, when I plugged that into Power BI, it kind of, it had a little bit of a problem with that because it couldn't label this stuff. So if I actually show you what I have for that, I believe it was, I think it's the itemized one. So let me open up that in Excel here. It's open on my other screen here. So yeah, if you exported your schedule, you might see that this has happened where you have, a multi-category schedule, you have the family, you have that space. You may or may not have removed that when you were in Revit. So what you can do, that's really not an issue within Python. You could tell it to skip rows and it would know to skip over that. I think it treats blank as just nothing. So that means that it skipped this, it skipped just that, and then it treated family version, like it treated all that as columns. So rather than trying to tell Power BI to do a whole bunch of things, you could literally just say skip rows, and then it would just read it as if it was literally just this and then all your data sets. So very simple way that you can do that simply by just making Python do it. So pretty cool. But yeah, same setup here where you have the actual plot that you're doing. So it's just saying that it's a certain size. This is this plot here where it's just showing what is missing and what is not missing. So all of these here are all like parameters. If you wanted certain parameters that were, if they didn't show up in some families and they did in others and you want them there, this kind of shows holistically what percentage is missing across your entire library. So you would even see some duplicates here. In this case, a lot of this stuff, if you notice, the data sets I have are kind of like anonymized and just like extra stuff and whatever, just for illustration. But here you could see that it looks like there were two parameters that were called the same thing. So therefore you got a duplicate situation going on that maybe you got to check out, so it was shown here for illustration purposes. But yeah, if you find that in your own libraries, you could see that as like an opportunity to look further here, because you're seeing that things are missing or not missing and stuff like that. So again, this is just, again, like customizing the title, the text. There's another thing, if you notice here, there's a little bit of color with within the subtitle here, and there's also multiple titles. This was done with plt.title, and I believe it was plt.text. So those are two things you could look into, and you're placing that as well. But the thing is, what I wanted to say is that stuff's not default within Python. You're telling it to do that based on code. And if I'm not mistaken, you can't have the multiple colors in a title by default either, not even in Power BI, as far as I know. You'd have to trick it somehow. I come from more of like a Tableau background where I learned that first, I think, and then I dabbled more in Power BI. Tableau had the whole color feature thing where you could have multiple color titles and stuff, and I really can't let that go. I like my multicolored titles. I think it can add to it and allows you to take away other unnecessary things. I don't know if you saw from the this here I showed earlier. It's coloring things so I don't have to have a legend. That's one way you can get away with not having a legend. You can color it in your title, and then it can, and of course it's like corresponding a little bit with the chart a little bit. So you're like, you can kind of figure out what it is without having a legend instead. So to do that, you need to kind of, well, there's one way that involves like a ton of code, and the other way that I did here is really, you're just telling it to go in very certain places. So in this case here, I literally have like, let's see, 4 blocks of text. So this here is saying this block of text placed at this X and this Y. This is the text you want to put there. You can do a horizontal orientation if you want, or I think there's a vertical, or not, it's alignment, horizontal alignment, vertical alignment. You can do a font size, you can do a color. That literally does this first part here, and it's locating it at, looks like negative 0.5 in 95,000, which means it started at about here and then went up to there. So that's how it located it right there. And then it gets a little more tricky with the rest of it, where you're doing the same thing. In this case, it was starting at 4.4 and 95,000 here, and it was center oriented here, or center aligned rather. So if I went to like about 4.4, it's the center. So it's depending on how you want to go about it, but that's how you're locating where to put it. It's a little convoluted in a way, but I think it's worth it to try to get a multicolored title as opposed to having a bunch of extra stuff. So it's something you'd want to look into if you want to have multicolored stuff. again, this is a thing where you don't want to have the tools force what you can do. You want to have a vision and build the tools around it to make it happen. So cool stuff. What I wanted to show with the, where was it here? So along the same lines as this, I have a very similar one to show. This one I didn't, this one's not done with Python, I'll just tell you that, but this is called an alluvial. And if there are those of you who are familiar with the, I believe it's called Synoptic Panel, or OKViz, I think it's called. I used that as a custom visual here, and I tricked it to just understand to just import an SVG file. And this file was generated from a website called I believe it was rawgraphs.io. I'm looking for the website right now here. I had it up. It is, oh, there we go. All the tabs, the crazy tabs. It is right here. So that's what this is. It's free and open source. You can create a lot of different crazy visuals. You can save or export the files as like project files. You can then go upload back into here and work on it again. And that's free. So this is the one that I built here. And basically you upload the data set. It's very similar. Like if you are in Power BI and you have to tell it to be a certain data type or something, you can do that here. You can do a lot of different stuff there. And you pick out what diagram you want. And you can do the mapping. In this case, I just had stuff all over the place because I wanted to show like what does this library look like across the whole thing. So you'll see things like the Omni class, assembly code, all that here. You can specify the colors, the width, like there's so many things you can get into here. And then it generates this whole large thing. And the thing that I want to highlight here is that, well, the gray here, I specifically colored for stuff that had that missing then. So if I were to look at this here, it's saying that so many files in this particular anonymized data set had keynote as missing, and several others had, looks like assembly description as missing and OmniClass. So you can kind of see where there's gaps within your Revit libraries if you're looking to organize your files in certain ways, because these are all just different ways of organizing things. So you can color stuff based on that. I didn't color every single one of these just because it kind of, I mean, in my opinion, I think it takes a little bit of time to try to color every single thing like this, but you definitely can color it. I just isolated the gray ones in this case, just to like highlight that this is not there. You know, it's not something that is in the data set, and you should look into it if you want that kind of thing. So that's a fun tool. So that's rawgraphs.io, fun tool, check it out. So that is that. I want to get to everyone's favorite, which is a pie chart. So this here's the typical pie chart that I see as a default in Power BI. I'm really not a fan, and here's why. The thing is with pie charts, it's very hard to tell the sizes between different slices here. In this case, yeah, it's a little more obvious that mechanical equipment is huge, and then this one's huge. But then you start to get into like, if you had so many other slices for some reason, then they start looking very similar and you can't really tell like what's different. Then you have to start looking at annotations here. So really a lot of times in the data science community, it gets a bad name because it's just so hard to judge the sizes of those slices. So there's ways to try to alleviate that a little bit. One way is to reduce the number of slices. I personally don't like using really any more than like 3, like maybe up to 5. I really don't like going more than that. I would rather show the data in a different way, but you know, it's all up to what you want to do. So, but yeah, this is the default one that I really don't like, and plus the colors. The colors is another thing we're gonna get to in just a second, but the colors, yeah, they're just colors. They're not really telling you anything of any significance necessarily. It's just here's color, you know. So I tried to recreate this. So this is a Power BI default visual, just straight up, just wanted a pie chart. This here, I tried to make it more of like a donut within Power BI. And then I also, what I did here, I tried to do the color schemes a little bit differently. And I thought, well, what if I tried to isolate like one of these as like highlighting something that I want the viewer to see. In this case, it kind of goes back to our pipe accessories example, where like the one file exceeded like, what was it, 1500 kilobytes or something like that. So I colored that one differently, and I made the others just kind of be kind of a muted deal here. And I also changed the annotations. Notice that this says 6.49, this says 6.5. I believe the term is called spurious accuracy, where it's just so accurate where it didn't really add to it. So that's why I made this go actually 1 decimal place as opposed to multiples. And I did 1 decimal place too, because if it was no decimal places, sometimes you might see that something doesn't add up to 100, and it should for a pie chart. So that's why I show it. So these things should be adding up, or at least supposed to be anyway. This one's a Python visual here. So if I click into here, it gets into very similar to what we've seen. You are importing the libraries, you are reading the data set. In this case, I had it doing a certain limit, and then I came up with a way to sort that to come up with that limit, obviously. I had some user input things to come up with color choices here. So I literally have the colors of this, but I wanted to show you this other one too, because this is how you could highlight things in your chart instead. So yeah, the first, or one of the choices that literally does these colors. This one is the one where it shows just the one highlighted one, and it kind of makes everything else fade away, because it's like we're focusing on this particular one. This is the one we really care about. So let's fade away the rest of them, just so you focus, or you make the reader focus on what you want them to see. And there's a really cool explosion effect happening, and that can be specified basically right within the pie here. So this here is saying you're plotting a pie, you are doing the font size, you are saying to do the colors. This explode line right here, it's saying to do excuse me, it's saying to do the, oh, I'm on the second choice, sorry. I have 2 choices, the color choice, like I said, and then this one. So 0, so it's saying like 0, 0, 0, 0, 0, and then this one is 0.3. So that's, you got to kind of locate where that one is, and then you make it explode out a little bit. So that's one thing you could do to really highlight or make something pop out if you wanted to show that a certain category of Revit families exceeds something or something like that. You can also adjust things like the starting angle. So in this case, it started at 90 degrees. You could specify that as something else. You could specify if it's going counterclockwise or clockwise. Lots of stuff here that we can only fit so much in the time here. But yeah, so we got that. Tree map, I'm going to try to go quick here. So the default tree map that you see in Power BI is, first of all, I'm sorry, this is really a lot of color, but this is what the default looks like. I want to show you this one. Let's get away from the other screen. But what this shows is very similar to like that one where we're looking at the missing attributes. This one will show what is similar across the board with attributes or parameters. So this is where you come across things like if they're a part number that's very similar to model number, that's very similar to parts or something, you'll see them highlighted in here with a diverging color scheme, because it's saying that this not only exists, it's saying that it exists like part of the time in your data set. Notice that family was not highlighted here, or family name. It's saying that, yeah, family name, you always have a family name, you always have that. And then it's not highlighting these very much because these are like obscure, like something maybe existed like once in your data set or something. So I'm saying don't worry about these as much. This is your opportunity to standardize things across your entire Revit library. So you'll come across things like the part and model number stuff. Maybe you want them the same name, or maybe you want your dimensions being very similar or something like that. So all that is in here is literally just coloring it. I believe I have the colors set up. There's a little formula button in here, and you can make that be 3 values, and you're just telling the middle value to be a certain thing. So, and you can of course format other stuff with this too, but that's one thing I wanted to show with that. Last but not least, let's get into the dashboards. So I did really quickly some layouts here. This is showing the same kind of stuff that we were just looking at. Of course, you can do whatever you want with dashboards. I'm just saying this is just an example of what you could do. It's pulling in those charts where you can copy and paste or whatever you want to do between them. There are other ones here too. That's the third one. And if you notice the colors here, they're all very similar in a sense where they're kind of like cohesive. That's very important because color choices matter in what you pick out. So let me go really quick over to Adobe Color. So I actually uploaded a photo, and you didn't know this, but the whole time I uploaded a photo and I actually came up with like a color palette based upon that. So you can do that as well. Just go to Adobe Color, it's free, you upload a photo, you can pick out a palette, you copy and paste. And of course, there are other ways of doing this too. But what's cool about this is that if you did this, you could also use Chrome extensions to check out whether these seem to work well for accessibility reasons. So the reason why we do that is because there are people who experience forms of color blindness. So you want to make sure that the colors you pick out, they're not blending together. That's why you need to pick out colors purposefully. So I have a couple up here. I believe it is this one. So this shows, let me go back. Okay, so this is the typical view. If you don't experience color blindness, that's what that would be. However, if you went to other ones here, you can simulate what that looks like. And then you may want to adjust your colors appropriately because you don't want them very close together. You can do this as well with contrast checking as well, which I can provide all of that for anyone interested. They're what do you call it, Chrome extensions and things like that. There's lots of tools out there for this sort of thing. But the whole point is that you are picking out your colors purposefully and you're making them cohesive too. Sometimes I change things on here based on what the whole layout looked like, because I didn't want to suggest like a color over here was different over here. So like in this case, I had out of box Autodesk content. I wanted to make sure that was like that orangish color compared to down here where I was using also out of box content. I want those to both stay orange. I don't want them to be different colors or something like that. They need to be cohesive. So I think I have a very similar thing here too. In this case, I had the pipe accessories as the orange. I had it highlighted orange over here. I also had it highlighted orange over here. So you try to keep it pretty cohesive because if they're close together on a dashboard, you just don't want things suggested to be different ways and stuff like that. It's all about trying to communicate those insights and have it be something where people aren't thinking too hard to see it. That's why the simplicity and stuff matters. So lots of things. So I think I got through everything that I could that will actually fit an hour. I do want to leave some time for questions. And I do know that there are so many little semantic and detailed stuff I could get into, but really this is what can fit in an hour. So I'm going to turn it on over to any questions if there is any at this time.
Yeah, it looks like we have a couple here. This one's from Kyle. And he says, I might have missed this, but how are you collecting all the source data?
That is a great question. So I have some Python scripts behind the scenes that are pulling names of files from, let's just say like a folder, and it's giving the names and stuff. So there's a little bit of that you could do. Also, the other way is through like Revit Schedules. Like if you literally just put all your Revit families in a project, you could export a schedule and you could get pretty much the same data set. I can show you what those look like here. Let me pull it up. So I got so many things here. Sorry, one moment. So if I open up this one. So any file that you have, any Revit file you have, you do have modification date time on the file. You do have last access date. You do have, I think there's a create date. Yeah, you have a create date as well. So you do have that, any file that you have. So I happen to use Python to generate all this, but this does exist if you look at any files that you have. I just happen to have a script that did this, but you could get at least the Revit family file names and stuff. This has been anonymized, by the way, but you could get all this from placing this in a Revit project. This here, this track start, this is, that's literally math of just saying UTC now minus something. So that's something like that. So you could write something like that to get it. I can only fit so much in a webinar, but I'm trying to show that you could get this from importing into like into Revit. So within Revit itself, you'd have like the actual types. You'd have like the actual manufacturer name, the actual model. I just anonymize this at this point, but you could get practically the same data set simply from placing your Revit families within a project. I'm hoping that answers the question. Let me know if not.
Okay. So we have another one here, and it's from Murray, and he asks, how did you create the data set, export the data set from your Revit files?
Okay, okay, well, I don't have Revit open right now, and it might take a minute, but basically if you have, gosh, I don't know what's faster, if I open up Revit and try to do it or what, but basically if you had, let's just say you had Revit open, you placed all your types, and then when you create a schedule, it'll give you an options of like, do you want this to be pipe accessories? Do you want this to be doors? Do you want whatever? I left it as a multi-category schedule. And then I just added fields in there. So within Revit, I'm doing this in my imagination right now. Within Revit, you'll add like a field like family, type, category, omni-class, like whatever parameters, it'll let you drag and drop those over, or not drag and drop. It's that window that has the all the fields you can pick from, and then you tell it to go over to the schedule. It's that prompt. You make that show up in your schedule. And then within that, you would go to, I believe it's file, and I think it's export. And it's like export Revit schedule. I don't have it open right now, and I'm really sorry, but it will export that as a TXT file. And within that, then you open that up in Excel. Excel opens up TXT files. You can tell it to do it with delimited, things like that. So you have it delimited. I believe it's with commas, if I'm not mistaken. And then it will actually just show like this. It'll just look like this in the end. If you have more questions, I can certainly follow up on that. I'm sorry, I don't have Revit open to actually do it. It would probably take a while for me to open everything up, but that's essentially the workflow to do that.
Cool.
We have other questions.
Yeah, we have one more. This one's from Reed, and he says, how often should I be updating data sets? Is updating too frequently an issue with large data sets?
Well, I think if you're talking about, well, if you're talking about like maintenance in general, the thing is, well, there's multiple components to it. So there's the Revit software component to it, like if that changes over time. So that's a thing to watch out for. Manufacturer specific content, I mean, that could change who knows how many times. I used to work for manufacturer, and you know, stuff would change over time that would affect the BIM content. So that's related specifically to the manufacturer, and that could be its own timetable thing as well. So basically when I presented all this stuff, I kind of think of it as like, you know, it's not your daily operational dashboard. This is probably like you're visiting it like quarterly or something like that. If you were trying to look for the latest and greatest from a manufacturer, plus whatever might be done with, you know, a certain Revit version over time. It really depends, as well as if manufacturers update their content over time and you're using their content too. So there's a lot of factors involved with that. But my main point is I don't think this is one of those things where you're running something daily or something like that. It's more like, you know, if you're looking at, well, across this whole library, you know, we're doing our maintenance aspects, you know, it's quarterly, or even if you did monthly or something, certainly not daily. I don't think you'd need to be a daily thing or something like that, but it really depends on a lot of factors on if you're using manufacturer content and if they're updating their stuff, and if you know, Revit functionality changes over time. There's lots of things, but my point is just, I don't think it has to be daily or anything like that. I'm hoping that answers the question. It's kind of a loaded one, I'm sorry.
I think that's it. I think that's all the questions we have.
Okay, well, just in case, if you do have questions or anything like that, this is where I'm at. So if you want to follow up with me, I do realize that I was like skimming over a lot of things, and it's because I built in a lot of custom stuff. So if you want to watch this space or like reach out to me or whatever, I can certainly help out further with that. It's just only so much can fit in a webinar, and I wanted to mainly show you that there's a lot more to it than the default, and there's just pick your rabbit hole, you know. That's kind of what it's like. And that's what I got. That's my story, and I'm sticking to it.
Cool. Well, if that's all, I guess we'll go ahead and shut it down.
Shut her down.
Perfect. Thank you so much, Giselle. This was great.
Thank you so much for your time, and thanks for watching.
Hey there, thanks for tuning in. If you like this video, make sure to subscribe and check out some of the other content on our channel.